They've invented a machine to fight climate change. They've invented it. I'm not kidding. It takes carbon out of the air. You think I'm kidding? This is a big deal. Not really. The world's biggest carbon removal plant just opened. In a year, it'll negate just 3 seconds worth of global emissions. I shouldn't laugh, but you have to laugh. It's so cartoonish. This is what they're doing. This is what they're spending their time on. Well, hopefully there's enough time to invent something else. So, well, this works. So one plant operating all year will negate 3 seconds of global carbon emissions. And so now all we need to do is build like about 1 billion of these. We need a billion of these. You think that's possible? We only have one so far. So maybe if we get 1 billion, let's start with 1 million. Let's see if we can get 1 million of them. This is... Maybe we can get 5 seconds worth by 2050. Is that what we should do? I keep laughing at my own jokes. I feel like a jerk. This carbon capture and storage facility named Orca turned on 2 weeks ago after more than 18 months of construction. The fans are embedded in shipping container-sized boxes. And once the carbon dioxide is separated, it gets mixed with water, then travels through snaking fat tubes deep underground where the carbon cools and solidifies. Does it become coal? Are you making oil? What are you making? Through this process, one can trap and sequester 4,000 metric tons of carbon dioxide per year, making it the largest facility of its kind in the world. Though there are currently only 2 running. So there's 2. We're on our way. There's 2. According to the latest report from the United Nations Intergovernmental Panel on Climate Change, carbon capture and storage is a necessary part of our best-case climate scenarios. Really? But currently, facilities like Orca only negate a sliver of global emissions. Today, the world's biggest carbon capture facility turned on. If it works, in 1 year, it will capture 3 seconds worth of humanity's CO2 emissions at incredible expense. I'm rooting for it, but only a fool.
Just bringing attention to. We've all seen this picture. This old geezer with the poster board, "The end is nigh." I agree with this old geezer, the end is nigh. Perhaps that makes me an old geezer too. But this I don't think is the biggest problem we face. I think that the end of habitat for humans on Earth is nearing its end. And the big problem is that the end is being totally ignored. We are not being told by almost anybody that the end is nigh, much less that the important feature is the end of habitat for human animals on this planet. With that in mind, I want to start with what shall we do? What do we do with this information that tells us our lives will be short? As Homer wrote in the Iliad some 2,800 years ago, quote, "Any moment might be our last. Everything is more beautiful because we are doomed." Wait, what? Homer in the previous paragraphs referred to the gods envying mortal humans. Why would the gods envy us mortal humans? Because any moment might be our last. Everything is more beautiful because we are doomed. You will never be lovelier than you are now. We will never be here again. Homer pointed out that the gods envy us for this. For the gods, one day is just like any other day. There's no reason to stop and smell the roses. There's no advantage to appreciating the here and now if you have forever yet to live. Oddly, this depiction of Homer in the lower left screen looks a lot like the person pointing out that the end is being totally ignored. We are in the midst of abrupt, irreversible climate change. As renowned professor Andrew Glickson pointed out in his October 9th, 2020 book, The Event Horizon, quote, During the Anthropocene, greenhouse gas forcing has risen by more than 2.0 watts per meter squared, equivalent to more than 2 degrees C above pre-industrial temperatures, which constitutes an abrupt event over a period not much longer than a lifetime. End quote. This is the very definition of abrupt climate change. Even the scientifically conservative Intergovernmental Panel on Climate Change admitted in their September 2019 special report on the ocean and cryosphere and changing climate that climate change is now irreversible as a result of an overheated ocean. Clearly, Earth is in the midst of abrupt and irreversible climate change. The ongoing rate of temperature rise indicates that Earth's climate will resemble that of the Pliocene epoch as soon as 2030, according to Burke and colleagues in their December 26, 2018 peer-reviewed paper in the Proceedings of the National Academy of Sciences. This paper relies upon the IPCC's conservative representative concentration pathways, which ignore aerosol masking and dozens of self-reinforcing feedback loops. Yet it indicates a stunningly rapid increase in global average temperature as early as 2030. The ongoing and projected rates of change are occurring rapidly enough to assure the inability of vertebrates and mammals to keep up. According to peer-reviewed papers in Ecology Letters on June 20th, 2013, in the case of vertebrates, and in the Proceedings of the National Academy of Sciences on October 30th, 2018, with respect to mammals. That humans fall into the category of vertebrate mammals ought to be of considerable concern. I mentioned aerosol masking, and I suspect many viewers are not familiar with the term. I'll explain briefly. At the same time, industrial activity produces the greenhouse gases that trap some of the heat resulting from sunlight striking Earth. Industrial activity also produces small particles that prevent sunlight from even reaching Earth's surface. These particles, called aerosols, act as something of an umbrella to keep sunlight from even striking Earth's surface. They prevent the sun's rays from penetrating the atmosphere, and they therefore preclude additional heating. According to the godfather of climate science, James Hansen, the aerosols fall out of the atmosphere within a few days. More than 24 peer-reviewed papers have been published on this topic, the latest of them indicating that Earth will warm an additional 55% when aerosol masking is lost, with an increase in temperature of 133% over land. 133% over land. This paper was published in the prestigious Nature Communications on June 15th, 2021. Loss of aerosols will take us to more than 3 degrees Celsius above the 1750 baseline very quickly. It is difficult for me to imagine many species keeping up with this rapid rate of environmental change.
I'm with you.
End Permian mass extinction event of roughly 252 million years ago, the worst such event in Earth's history, well, until now, has been linked to vast volcanic emissions of greenhouse gases, a major temperature increase, and the loss of almost every species in the oceans and on land. Now, it seems that even the lakes and rivers back then were no safe havens. A recent study published by an international team of researchers, including Professor and Head of the Department of Geosciences Tracy Frank and Professor Chris Fielding at the University of Connecticut, has identified a new cause of extinction during extreme warming events. Toxic microbial blooms. Where have we heard about toxic microbial blooms ramping up all over the planet? You can go right here in the lakes around Ithaca, New York, and there's warning signs about toxic microbial blooms. Don't let your little dog get anywhere near some of the lakes up here. In a healthy ecosystem, microscopic algae and cyanobacteria provide oxygen to aquatic animals as a waste product of their photosynthesis. But when their numbers get out of control, these microbes deplete free oxygen and even release toxins into the water. I'm not sure, again, if this hydrogen sulfide is one of these toxins they're talking about. By studying the fossil sediment and chemical records of rocks near Sydney, Australia, the researchers discovered that several pulses of bloom events had occurred soon after the first volcanic rumblings of the end Permian mass extinction. Once the bottom feeder animals, where all of this stuff sinks to, once the bottom feeder animals or detritivores were killed off, there was no one left to keep the microbes in check. The freshwater systems then seethed with algae and bacteria, delaying the recovery of animals for perhaps millions of years. Frank and Fielding study sediment, and Professor Frank explains their contribution to the work. Blah, blah, blah. Was in gleaning details about the conditions of the environment and the resulting toxic soup from the layers of sediment. Okay. The three main ingredients for the toxic soup are accelerated greenhouse gas emissions, high temperatures, and abundant nutrients. The volcanic eruptions provided the first two, and I'm a little bit confused here. I thought volcanic eruptions, so they release a bunch of greenhouse gases, but I always thought that volcanic eruptions cooled the temperatures. The particulate matter outweighed the greenhouse gases, but for whatever, I guess maybe these were volcanic eruptions without much soot in them. Who knows? For whatever reason, those volcanoes 250 million years ago gave us the greenhouse gas emissions with the attendant high temperatures, while sudden deforestation caused the third, which was providing the abundant nutrients. When the trees were wiped out, trees being wiped out, can't imagine that happening on the planet. The soils bled into the rivers and lakes, providing all the nutrients that the microbes would need. And of course, back then we did not have, sewage systems and agricultural runoff and septic systems and 8 billion humans adding all of this stuff to the soil, going into all of the rivers and oceans and everywhere else. Right, so when the trees are wiped out, the soils bled into the rivers and lakes. When the researchers compare the fossil records of different warming-related mass extinctions, the team found extremely similar fossil records. Wow. This implicates deadly microbial blooms as repeat offenders of freshwater extinctions during extreme warming events. Do you think so? Today, humans have been following this recipe, and freshwater microbial blooms have been on the rise, illustrating how important the geosciences are in understanding the past in ways that offer crucial context for understanding contemporary changes in climates. Quoting Dr. Frank, we are seeing more and more toxic algae blooms in lakes and in shallow marine environments that is related to increases in temperature and changes in plant communities, which are leading to increases in nutrient contributions to freshwater environments, you know, going hand in hand with the global temperature rising, you know, from the greenhouse gas emissions. So, a lot of parallels to today. The volcanism was a source of CO2 in the past, but we know that the rate of CO2 input that was seen back then was similar to the rate of CO2 increases we're seeing today because of anthropogenic, otherwise known as human-caused effects. We can get a sense of how much climate has changed in the past, what the extremes are, how fast it can change, what the causes of climate change are, and that gives us a nice backdrop for understanding what is happening today. Then they go and check out the IPCC report. According to this year's IPCC report, the influence of humans on the changing climate is unequivocal, creating conditions that favor the spread of these warmth-loving microbes in combination with the influx of nutrients from water pollution, mostly from agriculture and deforestation. This has led to sharp increases in toxic blooms today. The results: mass fish die-offs, severe human and livestock health effects, and an annual cost measurable in billions of dollars. Says Fielding, quote, "The end Permian is one of the best places to look for parallels with what is happening now." The other big parallel is that the increase in temperatures at the end of the Permian coincided with massive increases in forest fires. One of the things that destroyed whole ecosystems was fire, and we are seeing that right now in places like California.
We have such mega events right now today, yes, and we've had them from a few years from the research. For example, we've lost the Amazon rainforest. It's a very hard thing to say. The Amazon has tipped. It is no longer a carbon sink, buffering and soaking up some of our CO2 emissions. It has now started to emit CO2 emissions, and that is very, very clear from the satellite images. One of the things that I like to do, because it's pretty easy for me to recognize, is to look at the satellite images, which are now very, very, very precise and very definite. And the Amazon is pouring out CO2. The other mega event is that the Arctic has also switched. That was recognized first by the NOAA in 2016. They spent a couple of years on reviewing all of the research, and in 2019 they published that the Arctic has definitely tipped. When the wetlands are warmed up, they emit more methane, which is what they naturally do. The permafrost, though, is emitting all three of our main greenhouse gases. It's emitting methane, much more carbon dioxide than anybody anticipated, and that was just discovered by the research 5 years ago. So that is a absolute definite mega event, because we are, of course, going to lose all the Arctic sea ice. Then we're losing the cooling already, so we're losing cooling for months. Now, the ultimate mega event, getting more methane from the wetlands, emitting more permafrost carbon dioxide and nitrous oxide from thawing permafrost.
Temperature rising to 1.5 or 2 or 4 or whatever it is. In fact, I remember the Trump quote that 4 degrees would be just fine. So my question is, how do you reach the policymakers with some concept that will really get over to them that we have to make this enormous change in the way that we live and that we produce energy and keep our civilization going in enough time to avoid a real absolute catastrophe.
Brian, is there some way, if we were tracking human impact as a metric, instead of 1.5, 1.6 degrees of temperature, at least the politicians would take it more seriously because they have voters, or they eat food. There'll be some social impact that they might be able to relate to much more clearly than seawater rise of 1 millimeter per, that cares.
Well, we have lost the Amazon.
Yeah,
the Amazon rainforest. Now, if ever there was a metric that the policymakers should pay attention to, the other great jewel of planet Earth, right, is the Great Barrier Reef. Great Barrier Reef is gone. We've lost it. It's been lost by our politicians and policymakers continuing to support the fossil fuel industry. They just bailed out the fossil fuel industry with a massive economic renewal, in which over 50% of the money they doled out went to the fossil fuel industry. So they got their enormous metrics.
Well, let's not forget that, and please correct me if you don't see this the same way, but Bolsonaro, the head of Brazil, campaigned for president by saying he would burn the Amazon.
Right.
When you think about how much volume the oceans have in the mass, 3 degrees C is a significant change between glacial periods and interglacial periods. And then when you factor in how much added warmth that we have added to the atmosphere and how much the oceans have warmed up since, get an idea of just what we're doing and the difference between interglacial periods of the past, glacial periods of the past to the current. And then you couple that to what we're seeing with the energy in the oceans, what's going on in the atmosphere. You can see that we're basically putting in place a good runaway system. As I said in that ocean heat content, I'm seeing evidence that the thermohaline circulation is slowing. I'm seeing increased stratification of the
upper 500 meters,
which means that the distribution and sequestration of heat will not proceed as it has been, so that eventually the gases will stop being absorbed by the ocean. So those levels increase in the atmosphere. The oceans will outgas what already is dissolved at some point in the near future, most likely, further increasing gas concentrations, and therefore the temperatures that go with it. So I wanted to share this with you, a new methodology that is helping us to better understand how current conditions compare to past conditions, and then using the past condition, we can better project what the future will hold for us.
I shouldn't laugh. Every little bit helps, but just a reminder, this is really a little bit. Every little bit helps. Put another way, Kalmus told Insider, at any given moment, it will capture 1/10,000,000th of humanity's current emissions. It's remarkable to me it is being considered as part of those plans. I feel like neighborhood composting might do better than this.
Right?
I guess it depends on how many veggies you eat, but there's also the question of timing. The IPCC report says that without capturing significant amounts of carbon over the next 30 years, it will be impossible to get humanity to net zero emissions by 2050. And consequently, to limit warming to 1.5 degrees Celsius. I don't think that's happening. So yeah, we just need 1 million of these things, and everything will be fine. But Matthew Barlow, a climate scientist at the University of Massa-teatcher, Lowell said 3 decades isn't enough for the technology to be deployed widely. Damn it. There's no possible way for it to scale up on that time scale, Barlow, who contributed to the report, IPCC report, told Insider. If the Senate's infrastructure bill passes in the House, it would allocate $3.5 billion toward direct air capture facilities in the U.S. Oh, who's going to pay for that? The Orca facility does the work of 200,000 trees in 1,000 times less space, said the energy policy researcher at Columbia University. So maybe we should